I'm Mr. McBrien. This is TEJ3M, Breadboarding Basics. So today we're going to talk about circuits and how to make fast prototypes, the benefits of breadboards for this purpose, and we're going to talk about the best practices for good circuit construction. The Ontario curriculum suggests that we should do that. So they talk about safely constructing electronic circuits for interfacing or robotic applications. So this presentation, we're going to talk about what a breadboard is, the benefits of using breadboards, rules and guidelines for breadboarding. So this is a pretty standard breadboard. It is, on the surface at least, just a rectangle of plastic with a bunch of holes in it. What it is, it's a reusable platform for temporarily building electronic circuits. Now, it's useful to have a look below the surface of the breadboard. So here's an old style breadboard we can look at here, and if we were to cut away the plastic, we could see inside there are a series of spring clips. And these spring clips take the place of solder in our circuits. So when we take our electronic components and we push the leads through the holes in the top, they come into contact with these spring clips, and any other components that go through the appropriate holes, it'll be as if they're soldered together. So this is an extremely useful slide. So this is one you should really understand very well. And in fact, we've got an activity plan for you to investigate this further. But what we need to realize is that under the surface of the breadboard, along the outside, we have a very long spring clip that connects every one of those holes together. Anything we push into any one of these 20 holes will be connected to anything connected to any of the other 20 holes. Similarly, we have a line as well on the other side of the, or in this case, from our viewpoint, the bottom of the breadboard. Typical modern breadboards have 2 rails along the top and 2 rails along the bottom. Now, we also have these columns of 5 holes, and these have a shorter spring clip underneath, and these are used to connect individual components up. If we push a lead for a component into hole A1, any other component that we put into the 1 level will be connected to it. So we have 4 other places we can connect a component. Be aware of this break in the middle of the board. It has a specific purpose. So what this means is usually F, G, H, I, and J are not connected to A, B, C, D, and E. So why do we breadboard? And the answer is the same as usual. It's time and money. It takes less time to push component leads into holes on a breadboard than it does to solder them. And our alternative to soldering, printed circuit boards, well, they cost money and they take time to produce. At least as important, both printed circuit boards and soldered circuits are hard to make corrections. If we use a slightly incorrect resistor, it's difficult to make a correction on these, as opposed to a breadboard where we can change out the resistor very quickly. So for this reason, temporary circuits are usually breadboarded before we do anything more permanent. So here's some guidelines for breadboarding. First off, use as few jumper wires as possible. Use the breadboard to connect components together. When we do use jumper wires, we should keep them as short as we can. A jumble of wires is really hard to troubleshoot, and it's delicate, so it can be easily destroyed. Now, when you are breadboarding, what you want to do is lay out your components mimicking your schematic. So try to make them in the same geographic locations, and that'll make it easier to verify your connections at a later point. While we're on that topic, you should never breadboard without your schematic in front of you. Now, if you know what ICs are, that's great. If you don't, we'll talk about it later, but you need to put these in the middle of the breadboard. We'll explore that deeper at a later point. Now, as you work from your schematic and build your breadboard up, it can be helpful to take a pencil and just check off each connection as you make it on the schematic. So for this reason, paper schematics are often quite helpful as you're breadboarding. And if your circuit doesn't work, and this will happen to everyone at one point or another, it can be helpful to have a teammate check your circuit for errors for you. Often it just takes a new set of eyes to determine what the problem is. So as an activity today, be sure and watch the YouTube video Introduction to Breadboarding. And then I would like you to review Ohm's law and resistors in series and parallel before you use breadboards to test resistors in parallel and series. So you can design your own experiments and practice breadboarding, get out a multimeter and do some measurements. This should help you to develop your breadboarding skills as well as getting you ready for discussing parallel and series resistors. Now, if you don't have a breadboard handy, you can still go ahead and do these experiments. So Tinkercad has an excellent breadboard component in their circuit simulator, meaning that you can go ahead and breadboard circuits there, practicing your breadboarding skills appropriately, and even checking the functioning of your circuits. So this is an excellent way to, without needing all this hardware, to practice your breadboarding skills. Okay, to sum up, breadboards are a key circuit construction tool. Really, most circuit prototypes get built on breadboards before any soldering irons come out. And even very complicated circuits can be breadboarded quickly and efficiently once we've had a bit of practice. So go ahead and get out your breadboards and do some practicing, or you can have a look at tinkercad.com to do some work there. Thanks very much. Hello, here is our beginner's walkthrough of the solderless breadboard. I have here a simple breadboard available from virtually any online store for electronics. And it's a pretty standard device, really, and very important to the beginner in electrical engineering. Now, we've already talked about the benefits of this board. The main thing is we can build trial circuits very easily, make changes very quickly without having to do any soldering. We can make our changes extremely quickly. It's an inexpensive way to be able to work effectively with circuits. And while it may seem confusing at first, very quickly you'll become proficient with it to the point where you can go from schematic to circuit extremely quickly and easily. Now you're going to need more than just the breadboard. So you're going to need a series of leads, simple wires with the insulation trimmed from the end. You'll trim about 1/4 inch of insulation from them. You'll develop a whole, you'll wind up creating a whole bunch of leads that you'll use as you build circuits. You'll probably take a Ziploc bag or something and throw those in. Make sure you've got lots of different colors. Now, as far as the wires go, you can take a simple small thickness wire. If you're really strapped for budget, you can take a broken network cable, Ethernet cable, and use those. The wires need to be relatively thin to be able to fit inside the spring clips that we've talked about that grab hold of a wire. If we want to put a wire into a breadboard, we just push it into a hole, and the spring clip will hold it in place and form a reasonably conductive joint, a good stand-in for solder. If we want to connect anything up to our green wire here, we would simply push that other component into one of the other 4 holes that are on this column from my perspective on our board. So if I want to connect my black wire to the green one, I just choose a second hole and push it in. And now it's as if these are soldered together. But of course, once again, the benefit is we can just simply pull it out instead of having to cut or desolder the wire. Similarly, resistors can be pushed into here and so on. Now, because there's a break in the board from one bank of 5 to another, we can form much more complicated connections between our components by simply moving from one bank of 5 to the next. Now, you might argue, well, that doesn't help me because there's no power. And that is true. So the power rails are on the outside. We have to connect a power source, a potential source, to our board as well. So these power rails, I can connect up a potential source, for example, a 9-volt battery. Or if I have an adapter from a USB port, I can use that as well. Connect up power here, and connect up ground here, and now I know my circuit will need to run from my positive to my negative in order to work. Now, a few notes about good procedures. You can see here, hopefully, that a little extra of my wire has been stripped here. I've got about a 1/4 inch of bare wire sticking out here. This isn't particularly good practice. The reason why, we can have short circuits between components if we leave that in place. In general, you want about 1 millimeter of bare wire, no more, exposed above the board. So I should trim this down, get rid of most of this extra wire before I elect to use this. On the other hand, don't make the bare wires too short. If you do this, it's very hard to determine when you have a problem with a broken connection in your circuit. The benefit of having a small amount of bare wire here is when we go to use our multimeter later, we'll be able to get connection to this very easily by simply pushing our leads onto the location in the board. I might as well demonstrate that now. So I have a resistor here, and I have connected it to 2 separate locations on my board. The only way for current to flow between these 2 columns is through the resistor. There's a break between them. And this gives us an opportunity. We can go ahead and measure the resistance between these. We can disconnect the power from our circuit, which we've already done here. And we can press our leads firmly into these holes on the breadboard. And when we do this, pressing firmly in these locations, we can measure the resistance very effectively. And this is an excellent troubleshooting tool for us. So it is good to have a little bit of extra wire sticking up from each of your components, just not lots of wire hanging around to cause you trouble. So an additional handy tool for us to use is this adapter. So these can be found online at from various vendors, and these are essentially an adapter to a solderless breadboard that allow us to connect up. Let's make this correct. So allow us to connect up our power and our ground to the breadboard through a standard 9-volt connection. This is very handy in terms of being able to disconnect our power quickly. We can verify that we've got power. You can see the LED lighting up here to tell me that I do indeed have power to my board. This is a very handy device, if you can afford it, to add to your bench for breadboarding. Okay, so what about actually completing a circuit? Let's demonstrate that now. In order to do it, we're going to need an appropriate set of components. And we're going to essentially build a simple circuit, LED circuit, that we've seen many times before. So, what do we need to do? We need to first make sure we've got a schematic in front of us to remind us of what connects to what. And then we need to move typically from positive to negative. So in this case, I'm going to use my resistor to connect my bank of 5 to power. So to positive. And I've done this here. Hopefully you can see I've pushed the leads into the hole on the bank of 5 and pushed the other lead into positive. So I've connected positive to this bank of 5 using, in this case, a 1000 ohm resistor. Now, it isn't a complete circuit yet, but that's okay because we haven't got what we need to do work yet anyway. So I'm going to connect an LED to my resistor through that bank of 5. In effect, I've just soldered my positive end of my resistor, positive end of my LED to the end of the resistor. Next, and this is the key, I need to put the other end of the LED, not into that group of 5. I need to put it into another group of 5. So it needs to go across a break in the board. So I've done that here. I've gone from this group of 5 across the break in the center of the board to this group of 5. And there's only one step left. I need to connect the other end of my LED, the negative end of my LED, to ground. So I put one end of my black wire into the bank of 5 that contains the negative end of the LED, and the other end to the negative rail. Now, a note about good procedures here. You should really be using a much shorter lead. I've kept a long lead here so it's easily visible. As you're building up your cabinet full of tools, you'll have lots of short black leads available to you that will keep your wires down close to the board. And this makes them easier to troubleshoot. It makes it much tougher if you're moving that breadboard around to show to your instructor, or sometimes even to put in a prototype device. In my classrooms, we often have breadboards riding around on the top of robots, and we don't want a lot of wires hanging around to get caught on things. Stick to good procedures right from the beginning. Okay, should we see if our circuit works? This is always an exciting point. We can attach power to our circuit, and let's see if our LED lights up. And it does. It looks like we've done okay. Hooray for us. Okay, so there's your quick introduction to breadboards. I hope this has been useful. Go ahead and try things out on your own, and note that you can also use online simulators for this purpose as well. Have fun, and we'll see you next time.